Hello everyone. This video is on the Knewton Alta assignment for section 3.5 part 2 called Transformations of Functions. So in this video I'm going to be going over a preview version of this particular assignment. Please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. But all the objectives should be the same, so I'm hoping the questions are similar enough so that watching me do a few of them here helps you out in some way when you're working on them on your own. Alright, so on the assignment page you have the title, your mastery bar. You can see the objectives. It looks like there are 4 objectives for this particular assignment, so a bit of a longer one. Then under the current objective, you have a question related to that objective. And at the bottom of every question, you should be seeing a feedback button. So it allows you to send feedback to Knewton if you wish. You will not have an instructor cheat button. It's for instructors only. But you will have a more instruction button, which if you're struggling on a topic, you can click on this. It'll take you to some further reading or videos, and then you'll be given questions on that instruction, and hopefully all that stuff helps you get through the assignment better. Alright, so the first question I have is graph functions using reflections about the x-axis and the y-axis. And in fact, before I go into that question, I want to talk about, I'll make a little page or two where I discuss all the transformations. Let's just get them out of the way. So I'll talk about reflections across the x-axis and y-axis, vertical and horizontal shifts, and compressions and stretches. Alright, so first I think the easiest to discuss are the shifts. So I'm just going to write out the rules. Alright, I'm going to be assuming here that you've done some reading, that you've done a little studying, a little note-taking, maybe watch some of my other videos on these topics. So I'm just going to write out the rules for transformations. So given the graph of, say, y equals f of x, right, the graph of some function, you got your vertical shifts. You got vertical shift where the graph of y equals f of x and then plus k. So you leave the rule the way it is and just simply add a number to it. If k is positive, you just move up k. You shift up k units. If k is negative, you shift down, the opposite of k units, or the absolute value of k, right? Because k is negative, but I want to go down a positive. When you're counting movement, it's a positive movement. So I'm saying down the opposite of k. By the way, you add a positive number to a rule, it moves the graph up. You add a negative number to a rule, it moves the graph down. That's really all you need to know. Right, then you have your horizontal shifts, moving the graph to the left or to the right so many units without changing the shape. Right, these shifts don't actually change the shape of the graph, they just move it around. So again, we start off with y equals f of x. Now if I replace the x's with x minus h. Replace x with, if I went through the rule and replaced all the x's, all the inputs, with x minus some number. If that number is positive, so like x minus 1, x minus 2, right, the graph's moving to the right. H units. And if h is negative, so x plus 1, right, minus negative 1, minus negative 2, so x plus 1, x plus 2, x plus 3, replace all the x's with that kind of stuff, the graph will shift left, the opposite of h, or the absolute value of h units, right, just to talk about it being positive, right? Okay, so for you'll notice also for vertical transformations, you keep the rule the way it looks and do something outside of it, and you're going to see that for all the horizontal transformations, you go to the rule and you just change all the x's into something else. All right, so x minus h here for horizontal shifts. All right, and then you have your stretches and compressions. So let's talk about vertical stretch slash compression. All right, now vertical stretch means, you know, the points are moving away from the x-axis. So let's say this is the x-axis here. A vertical compression means that the points of the graph are pushed in closer to the x-axis. This is where you have y equals, and then, you know, again, you just take the rule the way it was, y equals f of x, leave it the way it is, but multiply the whole thing by some number a, right, a times f of x. Where right now we're going to focus on a being some positive number, because if a is a negative number, that's going to cause a reflection, as we'll see at the end here. So if I multiply the whole thing by a positive number, if that number is greater than 1, you have a vertical stretch. And then they say it's stretched by a factor of a, meaning that all the distances from the x-axis gets multiplied by a factor of a. And if a is between 0 and 1, so like I multiply the whole thing by a half or 2/3 or whatever, 3/4, you get a vertical compression. Once again by a factor of a. And again, all that means is, you know, all the distances from the x-axis are multiplied by a. And if it's less than 1, you know, the distances are shrunk. If it's greater than 1, the distances are increased, you stretched. All right, then you have horizontal stretches and compressions. Now, this is where you're dealing with the y-axis. A horizontal stretch means the points on the graph are getting pushed away from the y-axis. A horizontal compression means all the points of the graph are pushed toward the y-axis. The distance to the y-axis is smaller. So I take, now like with all the other horizontal transformations, you take the rule you were given and replace just the x's. So we have a y equals f of, and then x is replaced by some number b times x, right? So x is replaced by 2x or 3x or a half x or whatever. And we're going to consider b a positive number again here, because if b is negative, then you talk about reflections, which we'll get to in a second. Alright, so this time if b is bigger than 1, so I replace all the x's with 2x or 3x or 4x. This actually causes a horizontal compression. So all the points are moved in closer to the y-axis, and it's by a factor of 1 over b, the reciprocal of b. So for instance, if I replace all the x's with 2x, the distances from the y-axis would get cut in half, the reciprocal of 2. If I replaced x with 3x, all the distances from the y-axis would be multiplied by a third, right, the reciprocal of 3. And then if b is between 0 and 1, so if I replace all the x's with half x or a third x or 2/3 x, you're going to get a horizontal stretch. The distances from the y-axis will get pushed away, will get larger. You'll get a horizontal stretch. And again, by a factor of the reciprocal of b, of 1 over b. All right. And now you have your reflections. So a vertical reflection, which in other words would be called a reflection across the x-axis. A vertical reflection, in other words, across the x-axis. And you're given y equals f of x. Again, anything done vertically to a graph is done on the outside. You keep the rule the way it is, and then just multiply it by -1. Y equals negative f of x. This is going to be the graph of f reflected across the x-axis. Very simple. And then horizontal reflection, in other words, reflecting across the y-axis. And anything done horizontally, you just take the rule and replace all the x's with something. And here, it would be y equals f of, and then x is replaced by -x. Replacing all the x's by -x reflects the graph of f across the y-axis. Right, because you're taking all the x coordinates and then, making them the opposite, taking them across the y-axis. Here you're doing the opposite of the y coordinates, so reflecting across the x-axis. All right, and I'll keep referring back to these, but these are all your transformations. Vertical shift, horizontal shift, vertical stretch or compression involves multiplication, horizontal stretch or compression, right, replacing x with some number times b, right, with some number times x. And then vertical reflection across the x-axis and y-axis, right, which involves multiplication by -1 somewhere. Right. All right, so back to the problem. All right, now that I've written out all the rules for your transformations, all right, the exercise here, the graph of y equals f of x is shown as a red dashed curve with points, well, oh yeah, it is a red dashed curve. It's just under the blue right now. You can't really see it too well. But once I move these points around, you'll see the red dashed curve with points A, B, C, and D highlighted. Draw the graph of y equals negative f of x. So f of x, negative f of x, remember, multiplying the whole thing by -1, that reflects you across the x-axis. So I'm going to move points A, B, C, and D across the x-axis, meaning just take the opposite y-coordinate. So point A is 3 units, has a y value of 3. Its reflection would have a y value of -3. There's the reflection of A across the x-axis. Point B has a y value of 2. Reflect it, it'll have a y value of -2. There's point B reflected across the x-axis. Point C has a y value of 1. Reflect it across the y-axis. And there you go. And that has a y value of -1. Point D has a y value of -6. If I reflect this across the x-axis, it's going to have a y value of +6. And there you go. And now if you look at these, look at the red dotted graph and look at the solid blue graph, or whatever colors you're seeing. And hopefully you see that the red dotted graph and the blue graph are just a reflection across the x-axis. That's what happens when you take a rule and just multiply the whole thing by -1. Your graph is reflected across the x-axis, a vertical reflection. And I hope you can see it. I hope it's obvious here from the look of this picture. All right, then I'll submit. Great. And after every submission, right, it'll tell you whether you're right or wrong. You know, sometimes it'll give you another chance. But after your last chance, it'll tell you if you're right or wrong, and then you get some sort of answer explanation. Please read through the answer explanations, glance through them, just to make sure that you understand why you got something right or wrong, so you can try to learn from your mistakes for the future. All right, so let's move on. All right, so now we're into graphing functions using vertical and horizontal shifts. All right, vertical and horizontal shifts. So it's another one where, the graph of the red dashed curve, all right, the red dashed curve, that's f. That's y equals f of x. We're asked to drag the movable blue point to obtain the graph of y equals f of x plus 2, and then you see plus 3 outside. All right. So again, I'll just explain this. You have something that happened to the inside and something that happened on the outside. Now the outside stuff's easy. Plus 3, if I took the rule for f and just added 3 to it, that would move the graph up 3. So I'm going to move this blue point. Here's f. It would move up 3. So there's the graph of f of x plus 3. But then, you see how x is replaced by x plus 2 inside the function? All the inputs x are replaced by x plus 2. Well, if you do that whole x minus h thing, that'd be x minus negative 2, meaning, the h is negative 2. It moves left 2 units. So the plus 3 outside, you move up 3. The plus 2, x plus 2 inside, you're moving left 2 units. All right. So there's the graph there. It's the graph of the red dotted graph moved up 3, left 2, as indicated, by the new rule here. And again, you really got to just know those rules, right? All the rules that I wrote down for those transformations. And again, please read through the answer explanations. All right, so we're back to, again, this objective with vertical and horizontal shifts. All right, so once again, the red dotted graph is the original. I'm going to move the blue graph on top of it. So there's the original, y equals f of x. And it's just like the last one, move the blue point there to move the graph vertically and horizontally to match y equals f of x minus 2 plus 4. See, there's plus 4 on the outside, meaning up 4. 1, 2, 3, 4. There's the graph moved up 4. And then you see on the inside of the function where the inputs are, x is replaced by x minus 2. So the value of h here is positive 2. I'm moving to the right 2 units. And there you go, up 4, right 2. And that's all they want. So once again, you guys got to know all those rules that I wrote out for transformations earlier in the video. Just got to get them down. All right, compressions and stretches. So this will involve, some multiplication. So see here, y equals f of x is shown in blue. There's y equals f of x shown in blue. We're asked to move all these red points so that we get y equals f of 1/3 x. Now this one I'll show. I feel people have a hard time remembering the stretches and compressions, especially horizontally. So this is going to be some sort of horizontal stretch or compression, right? Because x is replaced by 1/3 x. Now 1/3 is between 0 and 1. So we're going to get a horizontal stretch by a factor of 3. Meaning multiply all the x coordinates by 3. That's going to triple the distance from the y-axis. You get a horizontal stretch. So I'm going to do that back on this graph. So you see 0, 0 here. When you multiply the x coordinate by 3, it's still 0, 0. This point is 1, 4. I multiply the x coordinate by 3, now it's at 3, 4. So there. Now this point on the blue graph was at 3, 4. I multiply the x-coordinate by 3, it's at 9, 4, there. And then this point's at, 4, 0. Multiply the x-coordinate by 3, you get 12, 0. And there you go. All right. This red graph is the blue graph horizontally stretched by a factor of 3. Right? Every point on the red graph is 3 times as far away from the y-axis as the points on the corresponding points on the blue graph. And that's what happens when x is replaced by 1/3 x throughout a rule. All right. Next. All right, so combining transformations, they might have some reflection or stretch or compression or shift. All right, so once again, here we're given, now they say the dashed curve is the original. So you know what, I'll just match up the solid curve to be right on top of the dashed curve. All right. Manipulate the green draggable points to obtain the graph of this function here. All right. Now, if I take the original, multiply by 1/3 on the outside. So I'm going to do the outside stuff first. Multiply all the y coordinates by 1/3. So right now, 0, 0, still be at 0, 0. It looks like, it looks like 3, 3 is on the graph. Multiply that by 1/3. Multiply the y coordinate by 1/3. You got the point 3, 1. So here's the graph, vertically compressed by a factor of 1/3. So I do the multiplication first. When I'm doing the outside stuff, the vertical stuff, I do multiplication first, then addition. And the inside stuff, I do the other way around. I do the addition first, then the multiplication. You've probably, and again, if you've seen other videos of mine on this topic, you'll know why. I'm just kind of assuming that you've read through at least some of the material at this point. And then -3 on the outside after means move it down 3. All right, so this point here, down 3 units. Cool. So that's the times 1/3, then the -3. I vertically compressed by a factor of 1/3, then I shifted it down 3 units. And now go to the inside, x is replaced by x plus 1, or x minus -1, right? H is -1, meaning move my graph left 1 unit. And there you go. That's all the transformations performed, all the vertical, all the horizontal transformations. This solid graph here should be the the dotted graph after all those transformations are complete. Wonderful. All right. So now we got reflections again. All right, so here's y equals f of x. Once again, they're just asking you to graph the reflection across the x-axis, right? Take f of x and multiply the whole thing by -1. So let's take the points and reflect the points across the x-axis. So this is what, 4, -5. That'll go to 4, +5. And the point here was at 5, -3. So that should go to 5, +3. And there you go. That green solid graph is the red dotted graph reflected across the x-axis. Right? All y coordinates are multiplied by -1. Here again, like the earlier problem with combining transformations, again I'm going to do the multiplication on the outside, then the addition. So first I'll have the graphs match up. All right. Now notice this times 2 out here. That means multiply all the y coordinates by 2, right? Vertical stretch by a factor of 2. So 0, 0 will stay at 0, 0. This 3, 3 will go to 3, 6. All right, there's a vertical stretch by a factor of 2. Then you got this -4 afterwards, moving it down 4. There's down 4 units. And then x is replaced by x plus 1 inside. which will move it left 1. Right? X plus 1 is x minus negative 1. And there you go. Caused a vertical stretch by a factor of 2, vertical shift down 4, and then a horizontal shift left 1. Did all that stuff. Great. Alright, more compressions and stretches. Alright, so here x, it's another horizontal stretch. X is replaced by half x. So it's going to be a horizontal stretch by a factor of 2, right? The reciprocal of a half. So I multiply all the x coordinates on the blue graph by 2. Now 0, 0 would stay at 0, 0. 1, 1 would go to 2, 1. Right? The distance gets doubled. The distance from the y-axis is doubled. It's a horizontal stretch by a factor of 2. This point here, 2, 5 would go to 4, 5. This point here, 3, 4 would go to 6, 4. Then this point here, 4, 4 would go to 8, 4. And this point here, 5, 0 would go to 10, 0. And now every point on the red graph is twice as far away as the points on the corresponding points on the blue graph are from the y-axis. You have a horizontal stretch by a factor of 2 when you replace x by half x, right? All the x coordinates on the original graph get multiplied by 2. Great. All right, more vertical and horizontal shifts. So again, there's a shift down. All right, first I'll match up the graphs. All right, here's the original. The minus 5 after, down 5. Right. So there's a shift down 5, and then x is replaced by x minus 3. So h in the x minus h is positive 3. That's a right 3. I move it to the right 3. So down 5, right 3, and that's all for that one. All right, so one more with the shifts here. So down 1, right 3. Right? There's a minus 1 afterwards. So here's the original graph. I move it down 1 unit for the minus 1 after. And then x is replaced by x minus 3. So h is positive 3. That's going to be to the right 3. So down 1, right 3. And there's the new graph after the transformations have occurred. Wonderful. All right, so that objective's done with the shifts. Reflections. Once again, we have just the whole thing multiplied on the outside by negative 1. That causes a reflection across the x-axis. If x was replaced with negative x, that would cause a reflection across the y-axis. Just pay attention. I hope you, like I said before, these questions I'm seeing, you might see some different ones. So hopefully you get some where you reflect across the y-axis too. But I'm reflecting across the x-axis here. So this negative 4, 1 goes to negative 4, negative 1. And then this point here, let's see, this point is at negative 2, negative 3. So that's going to go to negative 2, positive 3. And there you go. All right, see that red dotted graph and the green graph, the solid graph, are just reflections across the x-axis. Great. All right. I got one more here. Finally. See here, x is replaced by negative x, negative 1x. That causes a reflection across the y-axis, a horizontal reflection. So this point 2, negative 4 goes to negative 2, negative 4, reflect across the y-axis. And then on the red graph, we had the point 6, negative 5. That'll go to negative 6, negative 5. Oh, well, looks like that point's already there, but let's just move it. All right. I know it looked exactly the same. Oh, it won't move any further for some reason. All right, well, that should be good. All right, I mean, because the point -6, -5 is on there. All right, you have 6, we have 6, -5, and then we have -6, -5. So, and then 2, -4, -2, -4. The solid green graph and the red dotted graph are just reflections across the y-axis. Great. All right, so that objective's done with the reflections. So now compressions and stretches. All right, so once again, you see how x is replaced by 3x. Now remember, when x is replaced by bx, you multiply all the x coordinates by 1 over b. So replacing x with 3x is going to cause a horizontal compression by a factor of 1/3. So I'm taking all the points on the blue graph and multiplying their x coordinates by 1/3. So 0, 0 is going to stay at 0, 0. This is 1, 1. So that's going to go to 1/3, which is 0.333 here, 1. There. Now you see how the red point is 1/3 of the distance from the y-axis than the blue point. And then this is at 2, 4. Multiply the x-coordinate by 1/3. That's going to go to 2/3, 4, or 0.66, well, they'll say 0.667 there. Again, the distance from the red to the y-axis is a 1/3 of the distance as the blue is from the y-axis. And then 3, 0 is going to go to 1, 0. And there you go. The red graph, every point on the red graph is 1/3 of the distance from the y-axis as the points on the blue graph. You had a horizontal compression by a factor of 1/3 when x is replaced by 3x. Great. All right, and sticking with the compressions and stretches. All right, so every single one of these has been a horizontal compression or stretch. I mean, we've seen the vertical ones, but in other problems with the combining transformations objective. Just remember, if that 2 was outside, if that 2 in here was outside, if it was 2 times f of x, you'd multiply all the y coordinates by 2, you'd get a vertical stretch by a factor of 2. But that's not happening, right? Here we have x is replaced by 2x, so all the x coordinates need to be multiplied by a half. You get a horizontal compression by a half. So 0, 0 is going to stay at 0, 0. 1, 3 is going to go to 1/2, 3. There you go. This 2, 2 is going to go to 1, 2. This 3, 5 is going to go to 3/2, 5, or 1.5, 5. Let's get rid of these labels. Then this point here, 4, 1 is going to go to 2, 1. And finally, 5, 0 is going to go to 5/2, or 2.5, 0. All right, so there's your compression by a half, right? Every point on the red graph, every point on the new graph is half the distance from the y-axis as the points on the blue graph. All right, you had a horizontal compression by a factor of a half when replacing x by 2x. Great. All right, so that objective's done. I got combining transformations. All right, so here again, now this time, remember the outside stuff, I did multiplication first, then addition. Well, there's nothing multiplied on the outside of here, so I'm just going to do the +1. All right, so again, I'll have the curves match up first. Let's move it up 1. There's the +1, right, on the outside, a vertical shift up 1. Now the inside stuff. For the inside stuff, I do the subtraction or addition first, the shifts, then the multiplication. So to get this, I'd replace x with x minus 1, moving it to the right 1 unit. And then I would replace x with 1/3 x. Now if you replace x with 1/3 x, that multiplies all the x coordinates by 3. You get a horizontal stretch by a factor of 3. So all the x coordinates on this solid green graph get multiplied by 3. So this is at 1, 1 right now. Move that to 3, 1. And let's see, what else, where was that? That was at, well, let's say, 2, 2 is on this. That'll go to 6, 2. Alright, so 1, 1 moves to 3, 1. 2, 2 moves to 6, 2. And make sure 6, 2 is on this. There you go. And there you go. Alright, so all the points on the graph I just had, they got, triple the distance from the y-axis. Right? X got replaced by 1/3 x. After I replaced x with x minus 1, right? I would replace x with x minus 1 first, move it to the right 1, and then replace the x's with 1/3 x. Right? Do addition before multiplication with the inside stuff. That's just my recommended order. Wonderful. All right, now they're doing the other way around. They replace x with x minus 3. They do that, or they multiply x. Ooh, I see. They do the multiplication first, then the addition for some reason. I don't particularly care for that, but if you want to do it in the order they're doing it, be my guest. All right, then combine transformations yet again. All right, so this time, doing the outside again. I'll have the curves match up first. Then we got the times 3. All right, that's going to cause a vertical stretch by a factor of 3. So I mean 0, 0 is going to stay at 0, 0. 1, 1 will go to 1, 3. So let's move this here to 1, 3. Alright, and then the minus 3 after is going to move everything down 3. And then replacing x with x plus 4 or x minus negative 4 moves everything to left 4. And there you go. That's what the graph will look like after all the transformations have occurred. Alright. And it should have, oh, and that's it. Great. That's it for the preview version of this assignment. As I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same, right? So I'm hoping that listening to me here, watch me move all these points around, move all these graphs around, help you in some way when you do it on your own. And the key to all this is remembering the rules. Alright, so like I said, I'm assuming you've read through the text, section 3.5 from your OpenStax text. Maybe watch some other videos I've put out. Did some note-taking, practicing. But you got to remember these rules for vertical shifts, horizontal shifts, vertical stretches or compressions, horizontal stretches and compressions, and then reflection across the x-axis, reflection across the y-axis. Right? You just remember all these rules and how they're applied. You should have a pretty decent time, a pretty easy time getting through this assignment. All right, and thank you very much for watching.